But today is going to be a little bit different. We're going to start out by estimating square roots, and then we're going to simplify some square roots. So we'll see what all that means in a second. But let's start with the easier one, estimating square roots. What does it mean for you to estimate something? Anyone know what estimate means? To give an educated guess, right? Exactly. That's perfect. That's what we're going to do. Like if I said, what's the square root of 25? We don't need to estimate because we know that it's 5, right? It's a perfect square. But if I said, what's the square root of 26? That wouldn't be a perfect square. We'd have to kind of estimate what that's going to be. So we can find an approximate, which means kind of close to or almost, an approximate square root for these imperfect squares, as I like to call them. We can estimate these roots by identifying which two perfect squares your given number falls between. Go ahead and highlight that. Which two perfect squares your given number falls between. It's kind of like how a lot of people describe like where they live. Like if you guys, I assume most of you, if not all of you, live in Elk Grove. And if someone asks, oh, where do you live? You would use an approximate location. You would go, oh, I live by the Winco and the Shell gas station. You know what I mean? And if you've been around Elk Grove and you've lived in Elk Grove your whole life, which most of you have, you kind of know, oh, I know what area you're talking about. Or if you're like, oh, I live by, like between Food for Less and Edward Harris. I don't know, that's kind of a long distance, but you know what I mean, right? That's an approximation. So we're going to do the same thing here. If I ask you to find the square root of 18, is 18 a perfect square? Yeah. Well, let's check our chart. Is 18 anywhere on here highlighted? No. So it's not a perfect square. Okay, stay with me, please. 18 is not a perfect square, so we got to find the two perfect squares that 18 falls between. If I look back at my perfect square chart, my perfect squares are 1, 4, 9, 16, 25, 36. Where would 18 fall between? 16 and 25. Right? 16 is the closest number smaller than 18. 25 is the closest number larger than 18. So we could say that 18 falls between the two perfect squares, 16 and 25. Everybody with me so far? Yeah. We can tell that 18 is between 16 and 25, yes? So because the square roots of 16 and 25 are 4 and 5, again, 16 is equal to 4, 25 is equal to 5 when we take the square root. We can estimate, go ahead and highlight that right there, we can estimate that the square root of 18 is between 4 and 5. Like we said, between Food for Less and the Shell gas station, we're going between two numbers to get an approximate value. Let's double check and see. If I were to take the square root of 18, it was 18, right? Yeah. I would get 4.24. Is 4.24 between 4 and 5? Yes, it is. So that's what we're doing. We're not finding the exact value. We're finding the approximate value by estimating what two perfect square roots, ladies, what two perfect square roots would our number fall between if we did actually take the square root like we did here on the calculator. Okay? That's all it is. We're not really doing any math. We're more doing like, I don't know, I Spy with our little, where's that? With our little chart. We're finding what two highlighted numbers it falls between. We look at the little roots next to it. Boom, there's our answer. For example, if we have the square root of 68, right? We have to figure out, is 68 a perfect square? No. But which of these perfect squares is closest to 68, would you say? 64, right? Would 68 be smaller than 64 or larger? 68 would be larger than 64 and smaller than 81. So what two roots would the square root of 68 be between? 64 and 81, right? Those are the squares. The roots being 8 and 9. So we can fill in the blank. We can estimate the square root of 68 is between 8 and 9. Let's double check. Square root of 68 is 8.24. Is 8.24 between 8 and 9? Yes, it is. Quick show of thumbs. Is this making a little bit of sense how we're finding this answer? Good. That's great. Let's take a look at some examples here. We got a bunch of them. The easiest way to go about doing this is just figuring out what's the closest perfect square to my number given. If I've got the square root of 6, off the top of your head, what's the closest perfect square to 6? What was it? 2, 3? Getting a little ahead, what's the closest perfect square?
4.
4. Definitely. Now 6 is greater than 4. So we see it's going to be in between 4 and 9. So Ida, like you said, if we were going to estimate the square root of 6, what two roots are the small numbers, what two roots would this fall between, Ida? 2 and 3. So this is where we get a little bit confused, right? Because initially we're looking at the squares, the big numbers, so that we can tell what the roots, the small numbers, are going to fall in between. Again, we can double check. The square root of 6 turns out to be 2.4494. Is that in between 2 and 3?
Yeah.
Absolutely. It's a little more than 2, a little less than 3. I don't know why number 5 and 6 are exactly the same. You can cross out number 6, but give these 4 a try. See if you can follow that pattern. All right, make sure you're writing in pencil so that if you mess up when we go over it, you can change it. But see if you can figure out where these 4 imperfect squares fall between. Take a couple minutes to give it a shot. Yes.
Right.
That's right.
21.
Right, the small numbers. 7 and 3. So you said it's between 16 and 25, right? So the answer is going to be between 4 and between 4 and 5.
7 and 7. 7 and 3.
So the two numbers that it falls between are always going to be right next to each other. 7 and 3 are not right next to each other. Right? Yes, 7 times 3 gives me 21, but we're not multiplying. We're finding the square root. You know what I mean? So the perfect squares are highlighted, right? We're looking for the square root of 21. Where can we fit the square root of 21 in on this chart? In between which two numbers that are highlighted? Yeah, where would 21 be? We've got 1, 4, 9, 16, 25, 36. Where would 21 fall? In between 5 and what? So, you're not following. Look at the highlighted numbers. 1, 4, 9, 16, 25, 36. Which two highlighted numbers would fall on either side of 29? Boom. And let me show you what I mean. Come on. Yeah, let me put it in simpler terms. We got 1, we got 4, 9, 16, 25, 36. Right? Pretend this is a number. Right where 21 would be on this side. Beautiful. There's 21. So we're looking for 16 and 25. What's on either side of that number? You see what I mean? So what's the square root of 16? 4. What's the square root of 25? So the answer is between 4 and 5. You see what I mean? I know it's a little harder because the chart's not a number line, but that's kind of the way we want to think about it. I'll erase that. Give it a try or no? No? Let's say 17 and 18. Good. Let's say 11.
So if it was
Yes. So instead of doing the big numbers, you gotta write the small numbers. This will be between 9 and 10, or 5. Yeah, we're writing the roots, not the squares. Yeah. So we're looking for 90, right? You look at these highlighted numbers. What's the closest highlighted number to 90? 81 or 100. So my answer is going to be not in between 81 and 100, but in between 9 and 10. You look at the roots. Thank you. Yes. Here's number 4, number 5. Alan, you got a question? So let me show you this in a different way. This might help clear up some confusion, okay? So let's come back together for a second. Let's take a look at number 2. Number 2 is asking for what the square root of 90 is. Now 90 is not a perfect square. We're looking for the square root of 90, what it's approximately equal to. All right? So if we look at our perfect square chart, we've got 1, 4, 9, 16, 25, all these different numbers. I'm going to start at 25. We've got 36, 49, 64, 81, 100, 121. Let's pretend all these perfect squares are on a number line, just like this. Where would 90 fall on this number line? Devin? In between 81 and 100, right? There would be 90. You guys see how I figured out where that 90 goes? We're just looking on a number line. Now, the square root of 90 is going to be some long decimal number. But what's the square root of 81 equal to? 9. What's the square root of 100 equal to? 10. So the square root of 90 is going to be somewhere between 9 and 10. Does that make a little sense? Yeah, I see some blank stares. Give me a quick thumbs up if you see what we did there with the number line. If that makes sense. Does it make sense? Okay, let's take a look at another one then. Maybe it'll make more sense. Square root of 21. That one's easier because it's smaller. We're looking for the square root of 21. We want to estimate it. We're not looking for an exact number. We're looking for the closest. So I'm going to take all my highlighted numbers. I'm just pulling it off the chart, and I'm going to put them on a number line. I've got 1, 4, 9, 16, 25, 1, 4, 9, 16, 25, 36, 49, and so on and so on, right? Do you see 21 anywhere on this number line? No, because 21 is not a perfect square. We have to figure out, where does 21 fit on this number line? Would 21 fit right here in between 4 and 9? No. Would it fit between 9 and 16? 21 right there? No. What about between 16 and 25? Yes, that's where it fits. Okay? So we know that it's going to be in this range, between 16 and 25. But we want to find the square root. So what's the square root of 16? 4. Again, we're just looking at the chart. Square root of 16 is 4. What's the square root of 25? 5. Therefore, the square root of 21 has to be between 4 and 5. Because 21 itself is in between 16 and 25. Does that help a little bit?
Yeah.
Okay. We'll probably have more questions, but we'll cross that bridge when we get to it. Because this was the easier portion of today's lesson, unfortunately. So hopefully the next part will make sense. So like we said, square root of 90 is going to be between, what was it again? 9 and 10. Square root of 21 was between 4 and 5. What about the square root of 300? 17 and 18, because 300 would fall after 289 and before 324. Right? It's right in between these two. So it's between 17 and 18. What about the square root of 42? 6 and 7. 6 squared is 36. 7 squared is 49. 42 falls right in the middle of those. And number 6 is a repeat, so we'll get rid of that. All right. Let's move on to, now we're not going to estimate, we're going to simplify. So right at the top here, I want you to write in nice capital letters, simplify square roots. It looks like it says, looks like a P. There we go. Simplify square roots. Because you're going to be asked to estimate the square root, and you're going to be asked to simplify a square root, and they're very different processes. What we just did was estimating. In fact, on top of 4, let's write estimate, just so we know. I mean, we've wrote it twice already, but there it is. Because estimating is finding where the number falls between. Simplifying is actually finding a number. And we're going to only be dealing with irrational numbers, also known as imperfect squares. It's not what they're known by, it's just what I call them, imperfect squares. Like all the examples we just went over. 6, 90, 21, 300, 42. All of them imperfect squares. All the roots we found yesterday are rational numbers. Again, we'll talk more about what that means tomorrow. But what if we take the square root of a number that isn't a perfect square? For example, 12. We're going to follow the same exact process we did yesterday. Let's break 12 up into its factors, exactly like our warm-up. What two numbers multiply to give me 12? 6 times 2. Can we split up 6 now? Yeah, what two numbers multiply to give me 6? 2 times 3. So, if we multiply all these 3 out, 2 times 2 is 4, 4 times 3 is 12. Or from back to front, 3 times 2 is 6, 6 times 2 is also 12. Okay? If we look back, you don't have to look back, I just want to show you. If we look back, it's exactly what we did yesterday. The difference is today, we've got a little extra. Is there any identical pairs we can pull out here? Pair of 2s. Those are going to come out in front. Is there anything we can't pull out? The 3. So the 3 has to stay behind. It doesn't have a pair to come out with. So the 3 is going to stay inside that little square root. We can only pull out identical factors once we break these numbers up. Giving us an answer of, it's an ugly answer, but it's an answer, plus or minus 2 times the square root of 3. Now, if we did take the square root of 12, anyone have an estimate what two numbers the square root of 12 would be in between? Just like we did on the previous one, not breaking it up into its factors. Devin? Yeah, 12. Where would 12 fall between? 9 and 16. Good. What are the roots for 9 and 16? 3 and 4. So the square root of 12 should be in between 3 and 4. It sure is. 3.46 is in between 3 and 4. Now, if we did 2 times the square root of 3, we get the same exact number. So 2 times the square root of 3 is the same exact number as the square root of 12. I know this is going to get a little confusing, but let's just try and make it work. That's what we get, plus or minus 2 square root of 3. The important thing to note, identical factors get pulled out like before. Anything left over stays left over. So let's take a look here. How can we break up 18? What would my factors of 18 be? 6 and 3. What are my factors of 3? I'm sorry, what are my factors of 6? 3 times 2. Okay, we could also do a factor tree for 18. 6 times 3, 2 times 3, boom, boom, boom. 2 times 3 times 3, it's exactly what we get here. Okay, I'm going to make sure you guys understand how we got that for a second. Is there any identical pairs we can pull out here? Pair of 3s get brought out. Is there anything that gets left behind? The 2. So my answer is going to be 3, not over 2. We're not talking about fractions. 3 times the square root of 2. We brought the 3 out in front. The 2 stays behind. What do we need to write in front of this 3 now? Plus or minus. Great job. Plus or minus 3 square root 2. It's not a pretty answer, but that's our simplified answer. That's as much as we can do. So estimating, we're finding where this imperfect square falls between. Simplifying, we're actually pulling out everything we can and leaving a square root in our answer. Okay? Let's give the next one a try together. 24. Let's do a factor tree for 24. What two numbers multiply to give me 24? Bunch of different options here. 6 and 4. Sure, let's do 6 and 4. How can we break up 6? 3 and 2. What about 4? 2 and 2. So my prime factors are 3, 2, 2, and 2. 2, 2, 2, and 3 go inside like that. Well, hold on. Let's break it down. First, we want to look for a pair to pull out. Is there a pair we can pull out? Yes, we got a pair of 2s. Can we pull out this third 2 here? No, it does not have a partner. We got to leave it on the inside along with that 3. So in front, I again have plus or minus always. The 2 got brought out in front, so plus or minus 2 times the square root of what? 2 times 3, which is 6. So whatever numbers get left behind, if there's multiple numbers left behind inside the square root, you just got to re-multiply those back together. Yeah, Ross. Great question. The short answer is no. Now, when we're thinking about a square, right? We're talking about perfect squares. When we're thinking about a square, how many dimensions is a square?
4.
That's how many sides. How many dimensions? 2 dimensions. 1 dimension, 2 dimensions, right? So we can only bring out numbers in pairs of 2. Now, if we were talking about not a square, but a cube, how many dimensions are a cube? 3, because we now have depth, a 3rd dimension. 1, 2, 3 dimensions for our cube. So because we're talking about perfect squares, we have to think in 2 dimensions. We can only bring out pairs of 2. Yes? That's a conversation for another time. We don't have time to worry about that, but we'll talk about it later. Give number 20, not number 27. Give square root of 27 a try. Good. I heard someone say it. Give it a try on your own. Break it down, see what to pull out, what gets left behind, and give the square root of 40 a try too. Why not? And then we'll talk about it in a second. Sure. Good, great, perfect. Looks good.
So it'll be 3.
So, be careful, you can't pull out triplets. You can only pull out a pair. Like we did up there. See how we pulled out a pair of 2s, but we left that triplet 2 on the inside. You only bring them out in pairs. The same thing here. If we have 3, 3, and 3, one of those 3s has to get left behind. Yeah, let me start now. Yeah. Yeah. Yep. Exactly. And 5.
Oh.
Yeah. 2 times 2 times 2 times 5. We gotta wait a minute, Francisco.
Oh.
What'd you get? Nice. What are we missing in front of that 3? Plus or minus. Yeah. Great job. Good job splitting it up, bringing them out. Oh, 2, yeah. With a 0. Good. Great so far. Okay. Looks good reason so far. Brought that pair of 3s out. Something was left behind. Okay. So this is great. We got 3 times 3 times. Is there any pairs we can pull out there?
10, 5.
Hey, it's so
Yeah, there's 2 3s. So go ahead and circle those up. Bring them out in the front. Is there anything left behind? 3. So we've got a 3 in front, and then a square root with a 3 on the inside. And then in front of that 3 goes our little plus or minus. Great job. So this one, when we pull a pair of 3s out, we just pull one single 3 instead of a 9. Good, so I'll say so far. Great. Good. Nice. Great job.
she only if it's in the
Good. So 27, you have 3 Yeah. And that's great. We got a pair of 3s. So plus or minus 3. And still has a square root, and that's enough to Great job. All right, let's talk about this so we can get started on our work. All right, how can we break up 27? Someone help me out? Yeah, Ayana, what's 27? Perfect. Let's come back together for 2 minutes. 3 times 3 times 3 is any pairs we can pull out? Pair of threes. Again, we can't pull out triplets, just twins. We got to leave that third triplet at the hospital. All right. We got a plus or minus in front. What did we bring out again? 3. Is there anything left over?
Yes.
What's inside my square root? 3. Okay. So when we bring this pair of threes out, they become one single 3. We've got that one single 3 left on the inside as well. Okay? I swear, just give me 60 seconds, please. How can we split up 40? Let's break it down. We got 40. 40 is 8 times 5. 8 is 2 times 4. 4 is 2 times 2. I got 2 times 2 times 2 times 5. You got it. I just didn't want to go too quick. Any pairs here? Pair of 2s. Get brought out. What's left behind though? 2 times 5, good, which gives me 10. That's right.